All right, so we're going to look at some examples of solving equations that involve decimals. So for example, if we look at number one, when students read this, this is how they read it. So they'll say 2.6x plus 2 equal 1.4x minus 3.2. But mathematically, the correct way to read this is 2 and 6/10 x, because remember, the 6 is in the tenths place. So 2 and 6/10 x plus 2 equal 1 and 4/10 x minus 3 and 2/10. So in solving an equation involving decimals, you're going to use the same procedure that you use to clear fractions in an equation. And so we're going to use that same procedure that we use to clear fractions for decimals. All right, now the way you want to do this is this. Think of this as what it really means. So 2 and 6/10, right? So let's think about 2 and 6/10. So 2.6 like this is really means 2 and 6/10. And so what we're going to do is we're going to rewrite this mixed number as an improper fraction. I want you to notice what's going to happen. So when we rewrite this as an improper fraction, I get 10 times 2 is 20, and then 20 plus 6 is 26. So I get 26/10, right? So you see this 2 and 6/10 really means 26, so 2 6, and then that's in the tenths place, right? The 6, so it's 26/10. And so I'm going to rewrite this as 26/10 x plus 2 equal, and then do the same thing here. So 1 and 4/10 means 14/10. So that's 14/10 x, and then minus 32/10, right? Okay, and then all you do is do this just like you did the previous problem. So the least common denominator is 10. So you look at your denominators. You have 10. This is 2 over 1. So that's 1, 10, and 10. So your least common denominator is 10. And now we're going to multiply both sides by 10. And notice this side you have 2 fractions, and this side you have 2 fractional terms as well. So we're going to put both of those sides in parentheses. So we're going to say 10 times the left-hand side, just like this, equals 10 times the right-hand side. Now remember, from the previous lesson, the purpose of multiplying both sides by the least common denominator is to clear those fractions. All right, so remember we did at this point. So we change all of these decimals to fractions. And then we're going to multiply both sides by the least common denominator. So at this point, to clear those, or to get rid of those parentheses, I'm going to have to use the distributive property. So I'm going to multiply both of those terms that's inside this parentheses by 10, and the same thing here. So I get 10 times 26/10 x plus 10 times 2, so that's multiplication right here, equal 10 times 14/10 x minus 10 times 32/10. And so again, remember the whole point of multiplying both sides by the least common denominator is to clear those fractions. So basically you want, instead of this being a 10, you want that to be a 1, a factor of 1. And you do, because 10 to the 10 is 1, 10 to the 10 is 1. All right, over here my denominator is already a 1. Over here, though, I can reduce. 10 to 10 is 1, 10 to 10 is 1. So notice you've got to make sure you put factors of 1 here, just like we did here. Don't just cross them out. Make sure you put 1s, because that's what that really means. 10 to 10 is 1, 10 to 10 is 1. And now we're going to simplify what we have at this point. 1 times 26x, because 26 over 1 is 26. So 1 times 26 times x is 26x, plus 10 times 2 is 20, equal 1 times 14x is 14x, minus, and then 1 times 32 is 32. And so now I have a simple linear equation I can deal with. So I went from a decimal to fractions to an equation without decimals and without fractions. And so let's go ahead and solve this linear equation. So I'm going to go ahead and subtract 14x from both sides, just like this. Notice I'm combining my like terms. 26, I'm aligning my like terms and then I can combine. 26x minus 14x is 12x plus 20 equal 14x minus 14x is 0. 0 and a negative 32 is a negative 32. And then I'm going to, remember we got to get x by itself. So I'm going to go ahead, right now I'm adding 2. So I'm adding 20. So I'm going to subtract 20 from both sides, aligning your like terms. When I combine like terms, this is 0. Positive 20 and negative 20 is 0. I get 12x equal, and then a negative 32 and a negative 20 is a negative 52. All right? And then to get x by itself, you are then going to divide both sides by 12. So I'm going to divide both sides by 12 to get x by itself. 12 divided by 12 is 1. 1 times x is x. And then negative 52 divided by 12. That is not an integer, but let's go ahead and reduce this so far. So they're both even, right? So I can reduce each of those. They're both divisible by 2. They both have a factor of 2. So 52 divided by 2 will give us 26. So that's a negative 26. And 12 divided by 2 is 6. I can reduce this further. They're both divisible by 2. They'll be negative 13 thirds. And that's it. So there's your answer. So this is reduced form. If you want to write this as a mixed number, you can. So remember how to do that. You're going to say 3 and a 13 is 4. And then 4 times 3 is 12. Subtract, you get 1. So you get a negative 4 and 1/3. 4 and 1/3. So either one of those is fine. All right, and so that's how you do that. So that's how you're going to go from a decimal. You're going to change them to fractions, and then you solve the equation. All right, so let's look at another one. So this is going to be number 2. All right, so number 2, we have this. We have, all right, this is number 2. So we have 0.07x plus 0.3 equal 0.12x minus 10.4. All right, so notice I read it as point, right? But remember what this means. So this right here, 0.07 means 7. And remember the last digit is in the hundredths place. So that's tenths, that's hundredths. So this means 7 hundredths. So this is 7 hundredths x plus, and then you read this as 3 tenths because 3 is in the tenths place. So that's 3 tenths equal. So we're changing all these decimals to fractions. And that's going to be 12, and that's in the hundredths place. 12, the 2's in the hundredths place, so that's 12 hundredths x minus, all right, remember this is 10 and 4 tenths, right? But remember, you can rewrite this as 104 tenths. So that's 104 tenths. All right, because 4 is in the tenths place. All right, and so now we're going to find the LCD. Now remember, whenever you're changing decimals to fractions, notice the denominators will be multiples of 10. 10, 100, 1,000, 10,000, and so on. So that's how it's going to look. So notice 10, hundreds, you could have had thousands in another problem, and so on. But it's always going to be multiples of 10 because that's how we read decimals. Tenths, hundreds, thousands, 10,000s, 100,000s, and so on. Okay? So here the LCD, the smallest number that 110, 110 go into is 100. So we're going to do to this one just like we did in the previous problem. So I'm going to put on this side you have 2 fractions. On this side you have 2 fractions. So put those in parentheses, and I'm going to multiply by 100. So I'm going to say 100 times the left-hand side, just like this. All right. And then 100 times the right-hand side, just like this. Okay. All right. Now, remember, the whole point of multiplying both sides by the least common denominator is to clear those fractions. So the fact that I introduced parentheses means I have to use the distributive property. So I get 100 times that first fraction, 7 divided by 100x, plus 100 times that third fraction, 3/10, equals, and then 100 times 12 hundredths x minus 100 times 104 tenths. All right, very simple, not difficult at all. And now you're going to reduce. So remember, the whole point of multiplying by 100 is to get these fractions or these numbers down here to be factors of 1. And you will now. So when you reduce, 100 divided by 100 is 1. 100 divided by 100 is 1. Make sure you put those correct factors there. Over here, though, be careful. 10 divided by 10 is 1, but 100 divided by 10 is 10, right? Okay. Over here, 100 divided by 100 is 1. 100 divided by 100 is 1. Over here, 10 divided by 10 is 1. 100 divided by 10 is 10. And now let's go ahead and multiply. Let's go ahead and reduce. 1 times 7x is 7x, plus 10 times 3 is 30, right? Equal 1 times 12x is 12x, minus, and then 10 times 104. Remember, when you multiply an integer by a multiple of 10, remember you have 1 0, right? So you can move the decimal point one place to the right. So 100 times 10 is 1,040. 1,040. All right. And so now let's go ahead and bring all the variables to one side, constants to the other, since we have a linear equation. And I'm going to go ahead and bring the variables to the left-hand side. So I'm going to subtract 7x from both sides. So before I go on, I want you to notice I went from a decimal equation to a fractional equation to an equation in which you don't see any fractions or decimals. All right. Now, to be clear, I can write 7 as 7 over 1, and so you might say, well, that's a fraction. Yeah, but remember, the denominators are all 1s now, all right, because that's what you wanted. All right, and so 7x minus 7x is 0 when I combine like terms, and 0 plus 30 is 30, equal 12x minus 2x is 10x minus 1,040. And then adding 1,040 to both sides, and then combine like terms. 30 plus 1,040 is 1,070, equal, this is 0, and you get 10x. And then finally, dividing both sides by 10, I get this. Now, since I'm dividing by 10, this is going to be easy. I don't need a calculator for that, because I know that 1070 divided by 10 is just 107. So get x to be 107. And that's it. So that's number 2. So fairly simple, right? Not difficult at all. A fairly simple process. All right, but now let's look at number 3. So number 3 is going to be a little bit more challenging. Okay, so let's look at that. So number 3, we have 0.2 times 3y minus 5 equals 0.15 times 2y plus 3 minus 0.85. Okay? All right, so that's what I have. Now, there are a couple of ways you can do this. Probably the in this particular case, for the number 3, the way that number 3 looks, probably the best thing to do is to right away, let's go ahead and change those decimals to fractions. Let's do that now, because I think that might be the more efficient way of doing this. So just like we did in the previous problem, right? So the first thing I did was I changed all of these decimals to fractions. So let's do that here. So 2, remember this right here, 0.2 means 2 tenths. So I'm going to write this as 2 tenths times 3y minus 5, right? Y'all agree? All right, equal. And then this is 15. Remember, the 5 is in the hundredths place, so that's 15 hundredths times 2y plus 3 minus, and this is 85 hundredths. Okay? All right, now let's go ahead and get rid of the parentheses now. That's probably the next best thing to do. So I'm going to go ahead and distribute the 2/10 here and distribute the 15 hundredths. Now don't reduce, just leave it as 2/10, okay? Because remember, the LCD, when you do the LCD, it's going to be, in this case, you see where this is a 10, this is 100, this is 100, your LCD will be 100, right? And then that's always a nice number to deal with. Multiples of 10, 10, 100, 1,000, 10,000, and so on. All right, now when I reduce, I want you to remember something, and this is important, and some students have trouble with this. So you see this is 2/10 times 3y, right? So watch, this is 2/10 times 3y. Okay, now be careful. You got to think of this 3, you have to think of this 3 as 3 over 1, and then y as y over 1, if you have to. So you multiply the numerators together. So 2 times 3 times y is 6y. Okay, so that's 6y divided by, and then 10 times 1 times 1 is 10. So this is 6/10 y, right? So what some students make a mistake and do is they say 2 times 3 is 6, and then 10 times 3 is 30. That's not correct. That's not a 30. That's a 10. So if you're prone to do that, then it's a very good idea to rewrite 3y as 3 over 1 times y over 1. And then you multiply the numerators together, and then multiply the denominators together. Okay? And then over here, you're going to say, and I'm going to go ahead and write this one like this. I'm going to say minus 2/10 times 5, right? Equal, and then I'm going to go ahead and do this as well. 15 hundredths times 2y plus, and then 15 hundredths times 3 minus 85 hundredths. So that's what I did first. So I'm not using any calculator at all. These are simple numbers, computations to deal with. Okay, now just like we did with this right here, think about this right here. So remember, this is over 1, right? So that's 2 times 5 is 10, and then 10 divided by 10. So write it out. Say 6y minus 10 divided by 10 equal, same thing here, 15 times 2 is 30. So 15 times 2y is 30y over 100 plus, and then 15 times 3 is 45. So that's 45 over 100. All right, make sure you understand that. Make sure you understand why this right here is 45 over 100. So again, make sure you know why. So 15 over 100 times 3 means 15 over 100 times 3 divided by 1. Because I can write 3 over 1. So 15 times 3 is 45, and then 100 times 1 is 100. So that's what we see here, okay? And then minus 85 over 100. All right, now at this point, this is what I would do. At this point, I would go ahead and multiply both sides by the least common denominator, just like we did here. All right, so let's go and put both sides in parentheses, and we're going to multiply by 100. So I get 100 times the left-hand side, so 6y over 100. I'm sorry, 10, excuse me, 10, that's a 10, minus 10 over 10 equal, and then 100 times 30y over 100 plus 45 over 100 minus 85 over 100. All right, that's what I would do. Now, again, there are other things you could have done first. You could have, see how these two fractions are easy to combine. You could have combined that first. But I'm just going to do this. All right. Okay, so now I'm going to distribute the 100. Let's go ahead and distribute the 100. So I get 100 times 6y over 10. So I'm clearing I'm getting rid of the parentheses. I'm going to just use the distributive property. Minus 100 times 10 over 10 equals 100 times this fraction. So 100 times 30y over 100 plus, and then 100 times 45 over 100, and then minus, so that's this one right here, and then minus 100 times 85 over 100. Okay? And now let's reduce. So, remember the whole purpose of multiplying both sides by the least common denominator is to get these denominators to be factors of 1. So you want to clear those fractions. So 10 into 10 is 1, 10 into 100 is 10, right? 10 into 10 is 1, 10 into 100 is 10. 100 into 100 is 1, 100 into 100 is 1. 100 divided by 100 is 1, 100 divided by 100 is 1. 100 divided by 100 is 1, 100 divided by 100 is 1. Okay? All right, now let's go ahead and simplify. 10 times 6y, 10 times 6 is 60, right? And then I get 60y here. So that's 60y. Minus 10 times 10 is 100. Equal 1 times 30y is 30y. Plus 1 times 45 is 45. Minus, and then 1 times 85 is 85. So notice I went from a decimal equation that had parentheses to fractions. Then I distributed to get rid of the parentheses. And then I simplified to get this part here. And then at this point, I'm going to clear all those fractions by multiplying both sides by the least common denominator. All right, now on this side, I can combine these two terms. So I get 60y minus 100 equals, and then that's going to be 30y, and then 45 minus 85. So when you do 45 minus 85, you're going to get a negative 40. Okay? All right, and so now let's go ahead and bring all the variables to the left and the constant to the right. So I'm going to solve this linear equation. In this case, I'm going to subtract 30y from both sides. And then when I combine my like terms, I get 60y minus 30y is 30y minus 100 equal, this is 0, and then a negative 40. Okay? And then right now I'm subtracting 100, so I'm going to go ahead and add 100 to both sides. And when I do that, when I combine like terms, this is 0. I get 30y equal a negative 40 plus 100 is 60. Okay? And now dividing both sides by 30, my solution is going to be 2. 60 divided by 30 is 2. So the solution to this original equation, the real number that makes this original equation, the left-hand side equal the right-hand side, so the value of y that makes the left-hand side equal the right-hand side is when y is 2. All right, so notice the process. Now, remember, always follow the directions. So the directions will say, go ahead and solve this linear equation by first changing the decimals to fractions. And so that's what you want to do. You want to use multiples of 10. So 2 tenths, 15 hundredths, 85 hundredths. All right. So notice I did this without using a calculator. No calculator at all. All right. So it's very important you understand the way we're doing this. All right. And let's do one more. So it's going to be number 4. So let's look at number 4. All right. Number 4. We have 0.25 times x plus 3 minus 0.15 times x plus 5 equal 4. Okay, so you don't want to use your calculator, and you don't want to leave this as decimals. All right, so the way I want you to do this is to, first of all, we're going to change all these decimals to fractions. So 0.25, remember that means 25 hundredths. So let's go write this as 25 hundredths times x plus 3 minus, and then this will be 15 hundredths times x plus 5 equal 4. All right, so now let's go ahead and get rid of the parentheses. I'm going to distribute the 25 hundredths. And so I get 25 hundredths times x plus 25 hundredths times 3, right? Okay, minus Let's go ahead and distribute the negative 1500s here. A negative 1500s times x is a negative 1500s x, and then a negative 1500s times 5 here, equal 4. Okay? All right, so this one's easy right here to write as a nice term. So 2500s times x means 2500s x, right? All right, over here, remember what that means. So 25 over 100, so don't let that simple product right here throw you off. So 25 hundredths times 3 means 25 hundredths times 3 divided by 1. So multiplying the numerators, 25 times 3 is 75, and then the denominators, 100 times 1 is 100. So it becomes, right here, so it'll be 75 hundredths. So I get plus 75 hundredths. Now don't reduce, leave it like that because you're going to multiply both sides by the LCD, and you want the LCD to be multiples of 10. So either 10, 100, 1,000, and so on. All right, so minus, and this is 15 hundredths x, and then minus, and the same thing here. 15 times 5 is 75, so you get 75 hundredths equal 4. All right, so notice how simple it is. See, if you had reduced these right here, if you had reduced them, and then if you would have found the LCD, it would have been a little bit more challenging for you to reduce. So leaving it as this, you can see right away that the least common denominator is 100, right? 100, 100, 100, 100, and that's 1 right here, 4 divided by 1. And so I know right away the least common denominator is 100. So when I multiply both sides by 100, all of these denominators will automatically be 1s, and that's easy to deal with. So watch how simple this is. So I'm going to multiply both sides by 100. So remember the whole point of multiplying by 100 is to clear those fractions. So I get 100 times the left-hand side, 25 over 100x, plus 75 over 100, minus 15 over 100x, minus 75 over 100, right? Equal, and then this is 4 times 100. So 4 times 100. Don't forget, what you do to one side, you do to the other, okay? All right, and so now, let's see. I'm trying to think if I made a mistake here. 15 times 5, and then 15 times 5 is 75. Okay, so I'm good. All right, now let's look at what we have. So I'm going to go ahead and distribute like this. All right, and so I'm going to write it out. So I'm going to get 100 times 25 over 100x plus, and then 100 times the second fraction, 100 times 75 over 100 minus 100 times, times 15 over 100x, and then minus 100 times 75 over 100 equal, and then 4 times 100 is 400. All right, so let's go ahead and reduce. These hundreds divide out, you get factors of 1. These hundreds divide out, see how simple that is? You get factors of 1. These hundreds divide out, you get factors of 1. These hundreds divide out, you get factors of 1. And here's what you have. You have 1 times 25x is 25x, plus 1 times 75 is 75, minus 1 times 15x is 15x, minus, see that subtraction? So subtract, and then 1 times 75 is 75 equal 400. All right, now we're going to combine like terms. 25x right here minus 15x is, what's that, 10x? 75 minus 75, that's 0, right? So that adds to be 0 right here. So that's kind of, I'm going to try and cross them out to show you that that cancels out. That's 0. And then you're left with 400. And so now to get x by itself, you're going to divide both sides by 10, because right now you're multiplying by 10. So I'm going to write this over. And so when I divide both sides by 10 and then reduce, 10 divided by 10 is 1. 1 times x is x. And you get 400 divided by 10 is 40. And so there's your solution. So the value of x that makes this equation a true statement is 40. So if you substitute 40 in for x and then check this, you'll see that this side is going to equal 4. All right, so that is the 4 examples on how you're going to solve equations involving decimals. So you're going to change the decimals to fractions, and notice you're always going to have a factor of 10 in the denominator when you do that. Then you're going to multiply both sides by the LCD, and the LCD will be factors of 10, either 10, 100, 1,000. Then you're going to use the distributive property, and you solve for x. Notice nowhere did I use the calculator. All right. Okay, so that is the lesson on solving equations that involve decimals.